Hello everybody, we are into lecture 5 of bridge course. Okay, today we will be learning free fall and the sign convention which we have to use while solving problems related to free fall. Okay, before that I have got I want to give you a small work for you. There is a problem, solve this problem. You can pause the video also, solve this problem, and you please comment the correct option in the comment section. Okay, please do it. I'll read out for you once. An athlete completes one round of a circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? This type of problem we have already solved. If you are unable to solve it, you please refer to that. Okay, pause the video, solve the problem, comment the correct option. Okay, then today we will be learning free fall. What is free fall? Say, let us suppose that a ball is dropped from a particular height. After that, if the ball moves only under the influence of gravity, then we see that the object is under free fall. So before that, we have to learn something called sign convention while solving problems related to free fall. So we need to take proper sign for acceleration or displacement or velocity and so on. Okay, so sign convention, basically it is made for convenience. Okay, if you use that sign convention, you will get answers easily like that. Okay, without any mistake. Means sometimes whether displacement or acceleration or velocity, whether it is plus or minus, you have to tell exactly. Okay, only then we will get correct picture of the situation. Okay, we'll study sign convention. So what is sign convention? Let us suppose that there is a ball. Okay, this ball is been dropped. The ball is been dropped from a height. Okay, from some height. Okay, say from a height 5 meter. Okay, and here what convention we actually use is, in NCERT what they have taken is, they have taken upward direction as positive y-axis. Upward direction as positive y-axis. Then let us suppose that this is 5 meter. The ball is dropped. The ball reaches the ground. Okay, say this height is 0 meter because it is positive y-axis. This is origin. Okay, and say here the velocity is speed of the ball. Speed of the ball is 0 meter per second. Okay, here speed of the ball, let it be 10 meter per second. Speed of the ball is 10 meter per second. Whether it is plus or minus, we'll see later. Okay, now how to find displacement? Displacement is equal to final position minus initial position. Remember, displacement is equal to final position minus initial position. Okay, what is final position? Final position of the ball is 0. Okay, what is initial position? Initial position is 5 meter. Okay, so then what is displacement? Displacement equal to minus 5 meter. Okay, ball is coming downwards, displacement is minus. Okay, then velocity. What is velocity? Velocity is equal to rate of change of displacement. Displacement by time. Velocity equal to displacement by time. Okay, the ball is coming downwards. Displacement is negative. Correct na? Displacement is negative. Time is always positive. Time cannot be negative. Okay, displacement is negative. If displacement is negative, negative by positive will give you negative. So that velocity will be negative. Velocity will be negative. Okay, now what about acceleration? Velocity means negative. Okay, therefore this should be minus. Why? Object is coming downwards, displacement is negative, velocity should be negative. Okay, now what is acceleration? Acceleration equal to rate of change of velocity, or final velocity minus initial velocity divided by final time minus initial time. Okay, now what is final velocity? Final velocity is minus 10 minus initial velocity is 0 meter per second divided by time taken. Let us suppose that the time taken is 1 second. Okay, 1 second. So what happened? Acceleration is minus 10 meter per second square. So what you have to remember, the ball is coming downwards. Okay, displacement is negative, velocity is negative, acceleration is negative. What is the convention that we have taken? We have considered that upward direction as positive y-axis. It is very easy to remember because in 10th standard also, while plotting graph, we have taken this as positive x and this as positive y. Okay, when the ball is thrown upwards, say when the ball goes upwards, okay, during upward motion what happens? I'll write here. During upward motion, say the ball is thrown like this, thrown up, the ball is thrown up, okay, say this is 0 meter, correct now, say this will go to a height up to 5 meter, okay, the ball is thrown up with a velocity of 10 meter per second, okay, when the ball reaches the highest topmost point, okay, the velocity becomes 0 meter per second, correct now, okay, means as the ball goes up, speed of the ball decreases, ultimately it stops, velocity becomes 0. In this process, during upward motion, what happens? During upward motion, how to calculate displacement? Displacement equal to final position minus initial position. Final position is 5, initial position is 0, 5 minus 0, displacement is positive plus 5. If displacement is positive, velocity must be positive. Velocity must be positive. Why? Velocity equal to displacement divided by time. Displacement is positive, time must be positive, therefore velocity must be positive. What about acceleration? Acceleration is equal to final velocity minus initial velocity divided by final time minus initial time. Time is always positive, correct now? What is final velocity? Final velocity is 0. What is initial velocity? Initial velocity is 10, okay, divided by final time is 1 second, initial time is 0 second, okay, 1 minus 0, correct now? Time is always positive. So what happened? Acceleration is minus 10 meter per second square, okay. Whether the body is going upwards or downwards, acceleration is minus only. Why? It is very, very important, okay. You remember, ball is coming downwards, displacement is negative, velocity is negative, acceleration is also negative. The ball is going upward, displacement is positive, velocity is positive. Very easy to remember. But acceleration is negative. Why? Because we have an equation. See, you might have seen this equation. F is equal to m into a. Correct na? What does it mean? Direction of acceleration should be equal to direction of force. So therefore, force, see, when the ball is thrown upwards, earth pulls the ball downwards. Correct na? That is why speed of the ball is decreasing. When the ball is coming downwards, now also earth is pulling the ball downwards only. So therefore, acceleration always should be downwards. And according to our convention, we have taken upward direction as plus y, but acceleration is always downwards. Therefore, acceleration is always negative. You have to remember this. You need to summarize this. Okay, during upward motion. Okay, during upward motion, during downward motion. Okay, displacement, velocity, acceleration. During upward motion, displacement is positive, okay, velocity is positive, acceleration is negative. During downward motion, displacement is negative, velocity is negative, acceleration is always negative, because gravitational force always acts downwards. Okay, hope you can understand this. Remember this. Upward motion, okay, upward motion, displacement is plus, velocity is plus, acceleration is minus. Downward motion, displacement is minus, therefore velocity is minus, acceleration is always minus. Okay, keep this in mind. And now we are going to study free fall. Okay, now here the ball is dropped. Okay, the ball is dropped means what? Initial velocity is 0, u is equal to 0. Now we will see what will happen to the equations of motion. What is the first equation of motion? V is equal to u plus at. This implies ball is dropped, u is equal to 0, correct? Now u is equal to 0, leave this. What happens? V is equal to a into t. V is equal to a into t. But I'll write V is equal to minus 10 into t. Because when the ball is coming downwards, we know acceleration is minus. And when the ball is coming downwards, which acceleration acts on the body? It is acceleration due to gravity. Hope you remember in high school days, you might have heard something called G. Value of G is 9.8 meter per second square, correct na? Why the ball has acceleration now? It is due to gravity. That is why we call it as acceleration due to gravity. Value of magnitude of acceleration due to gravity is 9.8 meter per second. But for simplicity, we take minus 10. Okay. In most of the problems also, if you take minus 10, it will be fine. Or in the question, they will tell you whether you have to take 10 or 9.8. Correct now? So here we will take acceleration as 10 meter per second square. Since the body is coming down, acceleration is minus, v is equal to minus 10t. So this is one equation now. Okay, then what happens to the equation x is equal to ut plus half at square? X is equal to ut plus half at square. See, again u is 0, this term goes. Okay, so therefore x is equal to half into acceleration is minus 10 into t square. What happens? X is equal to minus 5t square. These are the two equations I have. Now I should calculate, we should analyze the variation of velocity and acceleration when the ball comes down. Okay, for that what I'll do, I will draw a table. The first column would be time in seconds, next displacement in meter, next velocity in meter per second, and the last one is acceleration in meter per second square. Okay, when the time is 0, what is the case? Okay, 2, so 1 seconds, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Let us see what happens. Okay, when the time is 0 seconds, when the time is 0, what about displacement? We'll see here. The same situation, we have substituted u is equal to 0. When the time is 0, t is 0, 5 into 0 square, 0. Displacement is 0. Like that we have calculated. Okay. So what about velocity? Velocity is minus 10 into 0. Okay, 0. Like that we have to do the calculation. You can do the calculation. Hope you are sitting with the pen and paper, notebook. I have asked you to do the notes. Okay, this is very, very important. Let us keep on calculating displacement first. When t is equal to 1, minus 5 into 1 square. 1 square is 1, minus 5. When t is equal to 2, minus 5 into 2 square. 2 square is 4, minus 5 into 4, 20. It is minus 20. 3. 3 square is 9. 9 into 5 is 45, minus 45. When t is equal to 4, 4 square is 16. 16 into 5, 80, minus 80. Yes. When t is equal to 5, 5 square is 25. 25 into 5 is 125, minus 125. Okay. What about velocity? T is equal to 0 is over. T is equal to 1, minus 10 into 1, minus 10. Then minus 10 into 2, minus 20. Minus 10 into 3, minus 30, and so on. Minus 40, minus 50. Correct now. Now what about acceleration? Acceleration due to gravity is always constant at lower heights, because see, F is equal to ma is the equation. Mass is constant now always, correct. Then at lower heights, gravitational, there is no much difference between gravitational force over this point and gravitational force over this point. Okay, at smaller altitudes, gravitational force is always constant. Therefore, acceleration is also always constant. Or you can do this. You can calculate acceleration like this. Okay, so in this interval, final velocity minus initial velocity divided by time taken, minus 10 minus 0 divided by 1 minus 0, minus 10. Okay, here minus 20 minus of minus 10, what happens? Minus 10 divided by 2 minus 1. Are you understanding what I'm doing? I'm using this equation, acceleration equal to final velocity minus initial velocity divided by time taken. Now in this interval, if you see, minus 40 final velocity, minus 50 final velocity, minus of minus 40, so minus 50 plus 40, it is minus 10, divided by what is the time taken? After 4 seconds, see, 5 minus 4, final time minus initial time, 5 minus 4 is 1, so minus 10 divided by 1 is minus 10. So everywhere acceleration is minus 10, everywhere. Okay, so here on the first step, okay, you make it a little confusion. Oh, here also you should write 0 now. Okay, see, if the acceleration is 0, say at the topmost point, when you drop it, when u is equal to 0, at the topmost point, if the acceleration is 0, what is the meaning? Acceleration means what? Rate of change of velocity, change in velocity. If change in velocity is 0, then this ball will not come down only. And one more thing you have to observe, when the ball is at the topmost point, now also force is acting on the ball, therefore acceleration should be there. Okay, because of acceleration only ball is coming down, because of force is only the ball is coming down. So throughout the throughout the trajectory, if a ball is thrown upwards, velocity of the ball or speed of the ball decreases, becomes zero, and then again increases. Okay, what happens to velocity? Velocity will be positive, it goes up, okay, decreases, becomes zero, then it becomes negative. But acceleration is always constant. Acceleration is always constant. You should remember this. Okay. Now, okay. So based on this, okay, we will solve one simple problem. Okay, or before that, okay, one simple problem. In the next class, we are going to discuss this table once again. Okay. Now we will solve one problem. I'll write a problem for you. Okay, very very simple. Okay, right along with me. A ball is dropped. A ball is dropped from the top of a tower. From the top of a tower. A ball is dropped from the top of a tower. Okay. It reaches the ground. It reaches the ground. It reaches the ground in 4 seconds. It reaches the ground in 4 seconds. The question is, what is the height of the tower? What is the height of the tower? What is the height of the tower? It's a very simple question. Okay. A ball is dropped from the top of a tower. It reaches the ground in 4 seconds. What is the height of the tower? Okay, height means we have to calculate distance traveled by the ball. Correct now. And the ball is dropped. Okay, fine. U is equal to 0. This is very, very important. Ball is dropped. A car starts. Means initial velocity is 0. Ball is dropped. Means initial velocity is 0. Okay. From the top of a tower. It reaches the ground in 4 seconds. T is equal to 4 seconds. Calculate the height of the tower. Means actually you have to calculate the distance traveled. Correct now. Then since initial velocity is 0, x you have to calculate. Means definitely I should go for this equation. X is equal to ut plus half at square. See, the ball is coming down. Ball is coming down. Okay. So x is equal to, x will be negative actually. Okay, we know ball is coming down. Displacement is negative. Okay. U is equal to 0. Correct. Now ball is dropped. So plus half into, acceleration is always negative, minus 10. We take g equal to minus 10 into t square. 4 seconds. T square, 4 square. 4 square is 16. Okay, 10 by 2 is 5. So x is equal to minus 5 into 16. 16 into 5 is minus 80 meter. Correct. What is minus 80 meter? Minus 80 meter is the displacement, because in this equation what is x? X is equal to displacement. Displacement of the ball is minus 80 meter. What does it mean? Ball is coming down. Okay. Ball has come down to a distance of minus 80 meter. Okay, that is why we have that minus. Minus symbol indicates that the ball is coming down. Therefore, what is the height of the building? H is equal to therefore 80 meter. Height cannot be negative. You cannot write it as negative. Height is equal to 80 meter. Okay. Can you understand? Okay. We will try to understand the table that we have written, okay, in a better way. Now if you observe, okay, if you observe this table very carefully, see, what is the distance traveled by the ball? Okay, what is the distance traveled by the ball in 1 second? Distance traveled by the ball in 1 second will be how much? After 1 second, displacement is minus 5. So distance traveled by the ball in 1 second is 5. Correct now? Distance traveled by the ball in 1 second is 5. Okay. What is the distance traveled by the ball in 2 seconds? Distance traveled by the ball in 2 seconds is 20. Okay. 3 seconds, 45. Now, you observe this. Okay. You observe this, very important. See, this 5 Distance traveled by the ball in 1 second is 5. Okay, this can be written as, I'm speaking about distance. Okay, this can be written as 5 into 1. Okay, distance traveled by the ball in 2 seconds is 20, so I can write this as 5 into 4. Distance traveled by the ball in 3 seconds is 45. I can write it as 5 into 9. Distance traveled by the ball in 4 seconds is 80. I can write it as 5 into 16. This I can write it as 5 into 25. Okay. Now what is the ratio? We'll see. Or I can write 5 into 1 as 5 into 1 square, 5 into 2 square. Correct now? 5 into 9 can be written as 5 into 3 square. 5 into 16 can be written as 5 into 4 square. 5 into 25 can be written as 5 into 5 square. Okay. Here we can write one very important point. What is that very important point? I'll just clear it. Okay. Distance traveled by the body in 1 second is to distance traveled by the body in 2 seconds is to distance traveled by the body in 3 seconds, okay, and so on, is in the ratio 1:4:9, or 1 square is to 2 square is to 3 square, and so on. This is one very important point that you have to remember for your NEET preparation and JEE preparation. Okay, now one more very important thing. Okay, what is the distance traveled in first second? 5 meter, correct? What is the distance traveled in first second? 5 meter. Distance, negative I am not considering. Okay. What is the distance traveled by the ball in second? Tell me, give me the answer. What is the distance traveled in second? That is 15. Hope you understand. That is 15 meter. Distance traveled in 1 second is 5. Distance traveled in 2 seconds is 20. Distance traveled in first second is 5. Distance traveled in second, okay, is 15. Okay. Now, distance traveled in third second is 25. See, 45 minus 20. Distance traveled in fourth second is 35. Distance traveled in fifth second is 45, and so on. Now, there is one important one more point. Distance traveled by the body, okay, when it is falling, when it starts from rest and moves with a constant acceleration, in first second is to distance traveled by the body, in second is to distance traveled by the body, in the third second, okay, is in the ratio 1:3:5. I forgot to tell you why is this. Okay, say this. What is this? 5 can be written as 5 into 1. 15 can be written as 5 into 3. This can be written as 5 into 5. This can be written as 5 into 7. Correct now? This can be written as 5 into 9. See the ratio. 1:3:5:7:9. So therefore, the ratio is 1:3:5. So we know that this point is known as Galileo's law of odd numbers. Galileo's law of odd numbers. This is also very important. If you know this particular point, sometimes some of the problems can be solved without any help. Hope you can understand this. Okay, this video is very important. Free fall, try to understand. Sign convention, try to understand. Try to understand the table. Draw the you write the table, acceleration, displacement, velocity on your own once. Okay, then you try to understand this. Distance traveled by the body in 1 second is to 2 seconds is to 3 seconds is in the ratio 1:4:9, or 1 square is to 2 square is to 3 square. Distance traveled by the body in first second, second second, third second is in the ratio 1:3:9, odd numbers. That is why we call it as Galileo's law of odd numbers. Okay, hope you can understand and you remember the first problem. Okay, correct option you put it in the comment section. Thank you very much.